Hello, this is Project 2, Serial Transmittive Temperature, for my software development for real-time operating systems class at Johns Hopkins, and my name is Joseph Alds. I'll start with the project requirements. So we were supposed to write a C program for an Arduino that captures temperature from a sensor and converts it to Fahrenheit. You must calibrate the temperature sensor, and you must wait for the temperature to stabilize before taking temperature readings. We were supposed to record the temperature every 10 seconds, starting with it at room temperature, and then place it in a refrigerator for 5 minutes, and then another 5 minutes back at room temperature. Then you were supposed to transmit the time and temperature via serial connection to the host, and then export results as a comma-separated CSV to plot the temperature versus time. So I chose for every 1 second to have an interrupt, read the data from the temperature sensor, and then take the average of the 10 previous temperature readings for the 10-second interval and then print them to the screen. So how? So first, power on, it will set up the serial and the interrupt. Then you'll go to a main loop. If it's the first 5 seconds, it will just wait and not start the timer or anything to actually capture the temperature. Once it's been 5 seconds, if the count equals 10, it will get the current amount of time the program has been running, calculate the average temperature over the past 10 seconds, reset the global temperature variable, and print time and temperature to screen, and then loop continuously. And then over here I have my interrupt, which is called every 1 second, which reads the current temperature. Here's some of the same things I just mentioned. The setup will set up the serial connection. It will print a welcome message and a header for the CSV file. The interrupt is where read temperature is called, and it also increments the global counter to see if it's been 10 seconds since the previous reading. Here's a schematic for my hardware setup. My kit has not arrived, so I had to use a temperature sensor I already had. I'm using an LM60 analog temperature sensor. So it just has power, ground, and then V out, which you can see are connected to my board here. So the hardware, as I mentioned, is an Arduino Uno, an LM60 temperature sensor, a breadboard, and 3 jumper cables. I use pin A0 to communicate with the LM temperature sensor. My software is written in C, and the software is compiled and uploaded via Arduino IDE. So here's my temperature versus time graph. You can see it starts at room temperature. It was a little cold because I had it outside at first. So I went from being outside to put it in the refrigerator through here. So you can see this temperature steadily dropping. And then here I take it out of the refrigerator and it goes back up to about 70 degrees for room temperature. So skip to here for the code. So I have a temperature pin being A0 for the analog pin. I have a float temperature global variable that I use to take the average temperature over the past 10 seconds. And then I have a global counter. So my read temperature function takes in a float analog read of the temperature pin. You can look up analog read Arduino library, but basically it chunks it into 124 sections, so 0 to 123. So here is where I'm converting it to Celsius. Converting it to millivolts. And yeah, the Arduino Uno with a VREF of 5, so I plug it into 5 volts, has 124 bits, 0 through 123. Here I convert that temperature to Celsius, and then here I convert that temperature to Fahrenheit. And then I add each Fahrenheit reading to my global temperature variable. Here's my timer, so I set, my interrupt, so I set the timer back to 0, so it resets for the next interrupt. It reads the temperature, and then I increment the global counter. Setup function, talked about a little bit, but it starts the serial connection, disables interrupts. Here's all the logic to create my timer interrupt. I use a prescaler of 256 to get 16 microsecond intervals. And then I set this to 62,500 because 62,500 times 16 gets 1 million microseconds. or 1 second. Therefore, the interrupt will occur every second. And then at that point, I re-enable interrupts. I print a welcome message and then the header for the CSV file right here. And then here's my loop. If millis, so that gets the time the program has been running, is less than or equal to 5,000. So less if the program's been running less than 5 seconds, I do not want the interrupt to increment the counter or add anything to the temperature, so I just set those to 0. So waiting the 5 seconds for the temperature sensor to stabilize. Once that's passed, if my count equals 10, so right here where my interrupt adds one to count, so every 10 seconds it will get the current time in seconds, and then it will get the average temperature, which is dividing this total temperature by the count, and then I reset those back to 0 and then print out the time and the temperature. So here you can see it has been running. So here's the output. The system will calibrate for 5 seconds, time and temperature, and you can see it's pretty stable, still running. And here's the actual breadboard setup. So there's my temperature sensor, and then there's where I have it connected to my Arduino, and everything works. Thank you for watching.